Can anyone guess how old this section of Engineering Hall that we're currently standing is? 1962. That's the year that this wing was constructed. Now what's going to happen once this ugly building gets demolished and rebuilt for a new engineering hall? What's going to happen to all the metals, the copper pipings, the aluminum on the chalkboards? What's going to happen to all of that? Well, hopefully they'll be recycled through urban mining. Urban mining is the recovery of materials from the technosphere. Now, technosphere, that's a kind of creative word that some techies made up, but that actually means it's the man-made products that we all make. That's everything from the desks, the chairs, to buildings. If it's covered in concrete, it's considered part of the technosphere. Now, the term urban mining is actually conceived in German. It's Stadtsparen. It means city prospecting. So in a sense, it is kind of like mining, picking out metals, picking out different parts that could still be repurposed. And I thought this is an interesting fact I dug up. Now, the demand for metals is currently higher than the combined production of all mines in the world. Now, here's a little demonstration with ELG company in Duisburg, Germany, about the process of urban mining. First, the scrap metals are either waste from a production company or just people who go out and find different metals. This is all collected by a company like ELG, which will take it and sort it on their lot. They test for the purity of the metals, and they also kind of pick out away zinc from, say, more expensive stainless steel. Now, to see if they truly have a good quality product, they cut off a piece and sample it. Here they are in the lab, where they're testing their large amount of stainless steel. One 200-ton shipment was worth 2 million euros at that time. So once they test it, see it's a good quality product, they take the scrap and load it into shipping containers. Here they're shipping one on rail to a neighboring factory in Germany. And here they are putting a shipping container to go to Taiwan. So this is really a worldwide industry, urban mining. Now, as they're loading onto the shipping containers, they send it to a the scrap metal gets melted down at 3,000 degrees centigrade, where it will then be repurposed and sold to producers who will fabricate parts such as beams, and then the products will be sold to consumers, which will reach their lifespan, and then flow back to where the scrappers will pick them out, and the process will start all over again. Now, why is urban mining important? Why do we go through this labor-intensive process, sorting metals out from tons and tons of waste? Well, this is why. On November 5th, 2015, a dam broke near Buenos Rodriguez, causing 34,000 square miles to be flooded with iron tilling water. This heavily contaminated the surrounding environment. It displaced 700 people from their homes and killed 17. Now, the companies BHP, Benetton, and Vale were responsible for a $44 billion lawsuit. The mining industry itself makes $1.23 trillion every year. Now, that very large profitable company, they should be held responsible for disasters like these. Thousands of workers die in Chinese coal mines every year. Along with that, there's numerous environmental concerns. Now, James will progress to the next slide and talk about those.
One of the benefits of urban mining is to reduce the environmental impact of mining virgin materials. Currently, there's a decrease in the reserve of virgin materials based off of our consumption of them over the past decades and centuries. Another benefit of urban mining is that we can try to reduce the competition for the virgin materials. And we can kind of see how that can be important in the future based off of political and economic dynamics. Kind of thinking of, as an example, how competition for oil has very much heated up of recent times, and it has led to a lot of conflicts globally and internationally. So by adopting more urban mining strategies, we can try to reduce the competition for precious metals and not quite go in the same direction as we have with oil and fossil fuels. Another benefit is looking at the economics of metals, and if we can increase the supply of metals through having more metals introduced to the market through urban mining as opposed to just mining the virgin materials, we can keep the prices down. And this is seen through simple supply and demand economics that we've probably seen myriad times in our introductory economics classes. So look at this diagram here. If we shift the supply downward, which is shifting it out actually, increasing supply, we can see how the equilibrium price drops down and effectively decreases the market price. Another important benefit of urban mining is it diverts some of the materials from going into landfills, and as we all know, landfills definitely have a bit of an environmental impact, a negative impact. That is, and of course, needless to say, the dynamic that prevents these materials from going into the landfill and exhibiting these negative environmental impacts is some of those resources get pulled out of the waste stream and get reused as raw materials or at least inputs to new products, which is, again, the overall goal of urban mining. Here we can just see some statistics of the environmental impacts of landfills and that sort of activity. We can see that as 0.03 gigatons of carbon per year associated with landfills. And that equals about 40% of the carbon emitted by the energy sector, to put it into perspective. So we can see those are quite big numbers. And of course, urban mining won't eliminate that, but it'll definitely serve to reduce some of that environmental impact. On a similar topic, we can also reduce the environmental impact of mining. Looking at these statistics here, we see that 1,470 gigatons of CO2 are emitted per $1 million of these metals listed up here, and that comes from the EIO LCA program that we looked at a few weeks ago to look at the environmental impact based on the economic activity of mining. And we can see also that we can reduce different impact categories, such as reduce the hazardous waste generated as well as the water used for mining. Now, if we look at the current status of urban mining, we'll see that it's definitely still in the nascent stage and it's not a fully developed industry or even a fully developed process of that, so to speak. Currently, where it stands is urban mining is really only done when it's readily accessible and not done on a short-term basis. So what that means is you're putting up a building and the materials are sitting there right on the site and they can easily be kind of pulled out of the waste stream. Then perhaps it might be done on a one-off basis on one particular project site, as opposed to contrasting that with a company that might specialize in urban mining. So if you're building company or a building rather, or a development complex, you might have a company in the future that will come in and provide the sole purpose or the sole service of urban mining and follow around the construction and be able to retain certain materials that will then go into the waste stream. But currently, as I said, that's not the case, and it's only done on a very small scale and opportunistically. There is large potential for urban mining to grow into. Some estimates from the literature suggest that half of the global sources of iron, the natural sources, natural reserves of iron and copper have already been mined, which says that if we keep going at our current rate, sometime in the foreseeable future we will run out of natural sources of these metals. And as we mentioned earlier, that's an important benefit inside to urban mining, is that we can kind of start to reduce this a bit. We also see a lot of times that the resources to be recovered through urban mining is typically concentrated in urban areas, so in cities, in developed places, as opposed to more rural destinations. Now, there are multiple different types of urban mining that we can kind of mix and match to optimize the effect we're going to be getting from urban mining in general. The first type of urban mining is something called secondary mining, and that basically goes back to old mining sites that were processed perhaps a couple of decades ago, somewhere in there. And we bring in new technology and new processes to kind of reprocess the waste material from the mining and try to get more of the ore out of the previously discarded tailings, kind of depending on the increased efficiency of our new technologies compared to what we were using for mining of the virgin materials a couple of decades back. The second option is, or the second type of urban mining is landfill mining, and that's pretty much what it sounds like, is going into a landfill and pulling out the valuable materials that you're going to be wanting to reuse, such as the metals. I mean, typically urban mining focuses on metals, but it doesn't need to focus solely on metals. You can look at other non-metallic materials as well. Another type is hibernation mining, and this is probably the most common so far type of urban mining, and that pertains to recovery of metals that have not been sent to waste management facilities, but they're currently not in use. So some examples of this are abandoned cables from the grid, or utility pipes or that sort of thing that are buried underground, but they're not actively being used anymore. Their active life is done in terms of their functionality. So we can see here, looking at the schematic, it's kind of a cutaway of perhaps a city street or something. We can see all the utilities below ground, which most of them, if not all of them, are are metal material as opposed to woods or plastics or something. So we can see the great potential for urban mining, and oftentimes all of these pipes and cables underground are not live and active and serving their design purpose. So that's kind of an example of where we can go in for hibernation mining and pull back some of those metals, and we can see that they're not in a landfill or any other waste management facilities, so it's not as easy just going to a landfill and picking them up. Now, these last couple are less commonly used types of urban mining. The first one here being dissipation mining, and that pertains to the recovery of materials that have been dissipated or emitted to the environment, and that's often in the form of capturing emissions. And this is, as you might be guessing, not very practical because emissions are very dispersed and diffuse. So the concentration at one particular point or one little volume that you could be working on is very likely to be low, and you don't necessarily know where the source came from. So it's hard to focus down and get to the source where the concentration is higher. Now, there's the potential to do this type of activity at potentially a stack that's emitting some emissions. So you can look more at the source, but that still is going to be rather low concentration of the metal in that emission, as opposed to taking a pipe or something. And the second and last main type of mining that we want to talk about is in-use mining, and that essentially refers to taking materials that are currently in use and reallocating them or reassigning them to a more desired function. And one of the main hurdles with this is a lot of times the material that's desired, that one party wants to reallocate to a new responsibility, that material is often owned by a private entity, whether it be a private citizen or a company or something like that. So of course you can work out ways in contracts to reshift and reallocate those materials, but you will have to work out the private ownership dilemma. So now I'll turn it over to Nicole at a remote location, and she will continue with the case study on this Scandinavian city.
Full of hibernation stocks of iron, copper, and aluminum. This is a map of the aluminum that's in hibernation in the city, and most of the highest concentration is in the middle, where the industrial parts of the city are. And then the next map is of copper, and the same thing. There's a higher concentration of copper in the industrial part of the city. And there are many challenges to urban mining. The first one being uncertainty, because you don't always know the quality of the materials you're trying to recover, and which materials can actually be separated from the waste. There's also the uncertainty of the concentration of materials. And the owners of landfills don't always have the knowledge how to extract valuable materials. And then there's also the high cost of urban mining. A solution to that is to incorporate urban mining more into redevelopment and maintenance projects. And then progressing into the future of urban mining, the waste management systems should be designed to accommodate more urban mining, to extract more valuable material. And then there also should be more development with for large-scale operations. And then you have to look at the economic benefit of it. Is it more economically beneficial to mine virgin materials or to urban mine? And then it also creates new jobs and new businesses. And then there should be additional research in the future to determine more effective materials and to identify the environmental and economic impact